On June 30th, 1908, something exploded over the Siberian taiga with the force of roughly 10 to 15 megatons. Near the Podkamenia Tunguska River, an estimated 80 million trees went down across more than 2,000 square kilometers. Then, investigators reached the devastated zone years later and found the detail that made no sense. No traditional impact crater, no obvious hole where rock or ice had punched into the ground. Near the center, some trees still stood upright, stripped bare, like poles in a burned-out landscape. That is the Tunguska problem. A blast vast enough to register across continents, but no crater to point at and say, there is where it hit. Into that empty center, three stories moved in. A cosmic object exploding in the air, Nikola Tesla's wireless power experiments, and later, a crashed UFO. Only one can keep matching the evidence. Before naming a cause, the record has to be sorted into three piles: evidence, inference, and speculation. Evidence is the part that can be checked. Witness accounts, seismic and pressure signals, maps of the damaged forest, expedition photographs, the missing crater, historical timelines, and later physical samples. Inference is what those clues allow. Trees pointing outward tell us about force. No large impact pit tells us something about where the energy was released. Speculation begins when the story needs a missing document, a hidden test, or a piece of wreckage the record does not provide. The mainstream explanation is not that Tunguska was ordinary. It is that a cosmic body entered the atmosphere and exploded before reaching the ground intact. That still leaves questions about size, composition, path, and breakup, but it makes testable predictions. The Tesla theory and the UFO crash theory enter under the same rule, not as punchlines and not as equal answers by default, but as claims that must survive the witnesses, maps, photos, timelines, and samples. The first problem for any investigation was simple. Tunguska happened in a place almost designed to delay one. Before anyone could read the fallen forest, Siberia slowed the investigation down. The blast happened in central Siberia, near the Podkamenia Tunguska River. Taiga, swamp, river routes, and long distances from the scientific centers of the Russian Empire. On a map, it is a point. On the ground in 1908, it meant few roads, scattered settlements, brutal seasons, and reports moving by people, rivers, and rumor. Remoteness did not make the event imaginary. It made it hard to verify. On the morning of June 30th, around 7:17 local time, people across the region described a brilliant object or flash moving through the sky, followed by heat, thunder-like detonations, shock, rattled buildings, and in some accounts, people knocked from their feet. Details vary, as eyewitness details often do, but the broad pattern is consistent. Light first, then sound and pressure, then shaking. Tunguska was not recorded only by memory. Seismic instruments registered ground waves. Atmospheric pressure disturbances traveled far beyond Siberia, leaving traces at stations across Eurasia. In the days after, unusual bright night skies were reported over parts of Europe and Asia, likely connected to high-altitude dust or ice effects. So the first reliable outline was not a crater or a recovered object, it was a pattern of waves moving outward. Human reports near the taiga, instruments farther away, and a damaged region no one could properly map for years. Russia then passed through war, revolution, civil conflict, and economic hardship. The first major expedition did not reach the devastated forest until 1927, 19 years after the morning the sky exploded. By then, the sound had faded. What remained was the forest, waiting to be read. When investigators finally reached the forest, it did not look like an ordinary impact. It looked like force had left a map on the ground. Leonid Kulik, a Russian mineralogist, led the first major scientific expedition into the Tunguska region in 1927. He came looking for meteorite material because a blast of this scale naturally suggested something from space had struck Earth. But the first major clue was not a fragment. It was the direction of the trees. Across a vast area of taiga, trunks lay flattened in long rows, as if a gigantic force had combed the forest outward. When Kulik and later investigators mapped the fall pattern, the lines radiated away from a central zone. Follow the fallen trunks backward, and they aimed toward the heart of the blast. That mattered because a forest can preserve the direction of force. A shockwave moving outward knocks trees away from its source, turning the landscape into a rough diagram of pressure and direction. Near the center, the pattern changed. Some trees still stood, but their branches and bark had been stripped away, leaving bare trunks often compared to telegraph poles. Instead of being pushed flat like the outer forest, they seemed to have taken a more downward overhead force. Together, outward fallen trees and stripped upright trunks pointed to an explosion above the ground rather than a solid object punching into the surface. Tree fall alone could not identify whether the body was stony, icy, metallic, or something in between. But it gave investigators something stronger than rumor: geometry. The blast had a center, the force moved outward, the damage was already hinting upward. Which made Kulik's next problem sharper. If something released that much energy over Tunguska, where was the crater? The loudest clue was the thing that was not there. Kulik expected the classic signature of a cosmic impact, a pit in the ground, scattered meteorite fragments, maybe heavy stones to collect and compare. Instead, at the center of one of the largest explosions in recorded history, he found swamp, burned trunks, flattened forest, and no confirmed traditional impact crater. At first, the scene feels wrong. If something from space can flatten trees across more than 2,000 square kilometers, you expect a scar on the map, a bowl, a hole, a clean place where the object met Earth. But that assumes the object reached the ground in one piece. A surface impact and an airburst are different events. In a surface impact, the body survives long enough to strike the ground, excavating rock and soil. That is where a crater comes from. In an airburst, the body breaks apart in the atmosphere, and its energy is released into the air above the surface. The destructive force still reaches the ground, but as pressure, heat, and wind, not as a solid mass digging a hole. That is why the upright stripped trunks near the center matter. They fit a force arriving from above, while the outer forest records the wave moving away from the blast center. So the missing crater is evidence. It rules out a simple ground impact, but it does not require a hidden crater, a secret site, or an impossible machine. It becomes strange only if Tunguska had to hit the ground intact. In 1927, the empty center still left room for imagination. Once the expected crater failed to appear, the mystery split. One path toward atmospheric physics, the other toward stories that filled the hole with something more dramatic. The first attached itself to Nikola Tesla. That empty center is where the Tesla story enters, not as proof, but as a claim built around the thing Kulik did not find. The claim is simple. Nikola Tesla, working from Wardenclyffe Tower on Long Island, supposedly sent destructive energy across the planet and accidentally or deliberately struck Siberia. It has the ingredients of a durable legend: a brilliant inventor, an unfinished tower, and an explosion in one of the most remote forests on Earth. Tesla's real ambitions helped the story stick. Wardenclyffe was not a cartoon machine. It was built for wireless communication and power transmission, tied to Tesla's serious dream of sending signals and perhaps energy without ordinary wires. The myth borrows force from something genuine. Then the timeline turns against it. Wardenclyffe was already in deep financial trouble years before Tunguska. J.P. Morgan withdrew support, construction stalled, and by 1906 Tesla had effectively lost control of the site as a working high-power project. Tunguska happened in 1908. For the weapon claimed to survive, Wardenclyffe would need to be not just standing, but secretly operational at a world-spanning destructive level. There is no direct evidence for that. The geography raises the burden further. The alleged shot would have crossed from Long Island to central Siberia, thousands of miles away, with no confirmed test record, no technical demonstration, no contemporary Tesla document tying him to the event, and no physical clue at Tunguska pointing back to a human transmitter. Tesla later spoke about powerful directed energy weapons, and those later claims helped attach his name retroactively to Tunguska. But later reputation is not a timestamp. A visionary inventor can inspire a legend without causing the event. The Tesla theory still tells us something important, just not about the blast mechanism. It shows how a real genius, a real unfinished tower, and a real missing crater can be braided into a story that feels plausible before the evidence is checked. On the evidence board, the label is historically unsupported. As that card fades, another story waits, born not in 1908, but after the world learned what nuclear explosions could do. The timing matters. The next famous explanation did not begin in the Siberian forest in 1908. It took shape in the nuclear age. After World War II, people had a new image in their minds, a city devastated not by an object striking the ground, but by an explosion in the air. Suddenly, Tunguska looked different. The flattened forest, lack of crater, and enormous blast wave had a modern reference point. In 1946, Soviet writer Alexander Kazantsev turned that resemblance into a story. In his science fiction framing, Tunguska was not a meteor, but a nuclear-powered spacecraft that exploded above the taiga. It connected two moments nearly 40 years apart: the unexplained Siberian blast and the new knowledge that an aerial explosion could erase a landscape without leaving a normal impact scar. But resemblance is not evidence. A nuclear-age reader could look at Tunguska and think of Hiroshima. That does not mean Tunguska was nuclear, artificial, or alien. It means the cultural vocabulary for catastrophe had changed. The same clue, no crater, had entered a new cultural frame. Researchers did examine traces. Soil, peat, tree resin, and microscopic particles from the region became part of the evidence trail. If an artificial nuclear craft had exploded there, the ground should have shown a very different record. Clear radioactive signatures, manufactured materials, or debris that natural processes could not explain. That is not what the confirmed evidence shows. Claims of exotic wreckage or a proven nuclear blast have not produced the physical record they would need. Some of the most interesting sample evidence points in a less cinematic direction. Tiny silicate and magnetite spherules with chemistry consistent with material from a cosmic body. The UFO theory earns a place in the story, but not as the solution. It shows how Tunguska was reinterpreted after humanity learned what nuclear explosions could do. The blast did not change in 1946, the imagination around it did. Separate the alien craft from the samples and the board looks cleaner. Particles, blast geometry, eyewitness light and sound, and the absence of a crater as pieces of one physical event above the ground. Put the clues back together, and Tunguska looks less like a ground impact and more like an object that broke apart in the sky. A cosmic body enters the atmosphere at enormous speed. The air in front of it compresses, heats, and loads the object with stress. If the body is fragile enough, or if the forces rise quickly enough, it breaks apart before reaching the ground. Much of its energy is released not as a neat crater-making collision, but as a violent atmospheric explosion. Now the clues start to lock together. It explains why Kulik found a forest pushed outward from a central zone. It explains why trunks near the center could remain upright but stripped, like poles blasted by pressure and heat from above. It explains why a crater was missing despite the immense energy. It also gives the microscopic spherules a place in the story, traces consistent with cosmic material, scattered after the object fragmented and burned. The object itself is still debated. Many models describe a stony meteoroid, perhaps tens of meters across, with estimates often around 50 to 100 meters, depending on speed, angle, strength, and composition. Others explore comet fragment possibilities. The key point is not one perfect measurement. It is that the physical evidence points to a natural body releasing its energy in the atmosphere. That is why Tunguska matters beyond folklore. An object small enough to vanish almost completely can still flatten a region larger than a major city. It can leave no classic crater, no recoverable boulder at the center, and still change the landscape for generations. Modern planetary defense starts from that lesson. The goal is not panic. It is detection, tracking, modeling, and time. Tunguska shows why the sky has to be watched before an object becomes a flash over the horizon. The remaining mystery is narrower and more honest. Not whether Tesla fired a weapon or whether a spacecraft crashed, but what kind of cosmic visitor entered over Siberia that morning and exactly how it came apart above the taiga. So the verdict is, not three equal doors. Some paths run out of evidence. One keeps matching the ground. The Tesla story has power because Tesla was real, brilliant, and ambitious. But the Tunguska weapon claim asks Wardenclyffe to do something the historical record does not support, at a time when the project had already lost practical footing. There is no direct link from Long Island to the Siberian blast. The UFO crash story shows how the nuclear age changed the way people imagined unexplained destruction. But its roots are later. Its strongest form came through fiction, and the physical traces at Tunguska do not point to an artificial spacecraft. The airburst does not remove every unknown. It leaves a narrower, better grounded mystery. Was the visitor a stony asteroid, a comet fragment, or something between those categories? What exact path did it take through the atmosphere? How did its strength, speed, and angle decide the shape of the blast below? Those questions remain because the object mostly destroyed itself before it could become a museum specimen or a crater in the ground. So Tunguska still has silence at its center. But the evidence around it is not empty. It is filled with fallen trees, stripped trunks, distant pressure waves, microscopic particles, and a lesson written across the taiga. The past rarely gives easy answers, but if we follow the evidence carefully, it gives enough light to see what kind of mystery we are really looking at.